Hello AP Chemistry, this is Mrs. Goswish, and this is still Chapter 4, the Types of Reactions chapter, and this is Section 6, and this is going to be writing molecular equations, complete ionic equations, and net ionic equations for metathesis reactions. Alright, a couple of things I want to go over for review. There are two types of reactions. This is a very broad category. Two types of reactions include metathesis, which is really hard to spell. Maybe that's why we like to call them double replacement reactions. And the second type of broad category is called oxidation reduction, which is of course a mouthful, so we like to refer to it shortcut as redox. The driving force of a metathesis reaction is the removal of two ions from a solution, focuses on liquid form. The driving force of a redox reaction is the transfer of electrons, and this can be any state of matter. Under the metathesis double replacement category, there are three subcategories: precipitate reaction, neutralization, and finally gas producer. It can be one of these three. Any chemical reaction will fall under one of the two categories. If it's metathesis, it cannot be redox. If it's redox, it cannot be metathesis. Keep in mind, double replacement is a metathesis reaction. That means some of the other reactions we are familiar with must be redox. Some other reactions that might fall under the oxidation umbrella is going to be single replacement, combustion, decomposition, and synthesis, to name a few. So here's a little picture I want to write on. This is an example of a metathesis reaction. And it is the precipitate. Category of a metathesis reaction. In this container, we have a soluble salt in solution, potassium chloride, potassium ions here, chloride ions there. It is a soluble salt. It is a strong electrolyte, so it dissociates 100%. Notice in the entire little image here, there's no compound potassium chloride, just the ions. This is reactant number 2, so I'm going to number them. This is reactant number 1, and here is reactant number 2. And this looks like it is soluble silver nitrate. This is also a soluble salt, again based on solubility rules. And if you look at the picture, you can see the nitrate anion and the silver ion. These two clear colorless solutions are poured together and you get products, one of them being a solid and a solution above it. All right. In the solid, you will find the silver chloride. According to the solubility rules, silver chloride is insoluble. Actually, we prefer to say slightly soluble now. So silver chloride is slightly soluble. Therefore, it becomes a solid. And in the solution part, you have the spectator ions. And the spectator ions are going to be the potassium and the nitrate floating around in solution. Look at the picture below it. Here's my silver chloride solid, and here's my nitrate ion floating in the solution, and my potassium ion floating in the solution above the precipitate. So here's my precipitate. All this stuff right here is the silver chloride solid, aka the precipitate, and above it, floating around in the solution, is the nitrate and the potassium spectator ions. Remember, it is the story of 4 ions, 2 in reactant number 1, 2 in reactant number 2. You pour them together. 2 of the ions, in this case, form a solid, and 2 of them do not. In neutralization, 2 of them will form water, and 2 of them will not. In a gas producer, 2 of them will form the gas, and 2 of them will not. The 3 equations for the metathesis reactions in order. You have your molecular equation. The molecular equation will list the reactants and the products in their molecular form, in their compound form. With the states of matter. And usually states of matter are the little AQ. A complete ionic equation. The ionic equation will show all the strong electrolytes dissociated into their ions. And the net ionic equation will contain only those solution components directly involved in the reaction after removing the spectator ions. Only the ions that are involved in the reaction. Okay, writing net ionic equations. Step number 1, write out the balanced molecular equation. You need to know how to write the correct formulas for the compounds because these will usually be given to you in word format. Step number 2, after balancing, dissociate all strong electrolytes. In other words, separate them into their ion forms. Step 3, cross out anything that remains unchanged from the left side to the right side of the equation. Those are the spectator ions. Step number 4, write the net ionic equation with the species that remain after you removed the spectator ions. Remember, when writing the complete ionic equation, only separate strong electrolytes. Be careful of magnesium hydroxide. It is a group 2A hydroxide, but it is not soluble, so do not include that as a strong electrolyte. Balance the molecular equation first before you write out the complete ionic equation. Now, just a little side trip here, please. I abbreviate molecular equation as the ME, the complete ionic equation as the CIE, and the net ionic equation as the NIE. So keep that in mind when we're running through these examples. Pertaining to subscripts, subscripts will only apply to that atom. For example, if I were to write out the dissolution reaction, and that's what this is called, the dissolution reaction of sodium phosphate. Sodium phosphate is a strong electrolyte based on the solubility rules. They break into the ions. There are 3 sodiums for every 1 phosphate. So this subscript of 3 applies to the sodium. Notice that this reaction, and this is like super important, this reaction is electrically and atomically balanced. 3 sodiums, 3 sodiums. A phosphate, 4 oxygens, a phosphate and 4 oxygens. 3 plus, 3 minus, 0 charge, 0 charge, because all compounds are 0 charged. Pertaining to coefficients. A coefficient gets multiplied through the entire compound. For example, 2 sodium chlorides, 2 sodiums, 2 chlorides. Again, notice, always balanced electrically and atomically. Alright, we are going to do some examples of metathesis reactions. And again, you need to know how to write these formulas, because on the AP exam and mine, they are going to be in word format. So it says that silver nitrate in its aqueous form reacts with potassium chloride in its aqueous form. Alright, this is a double replacement reaction, so I am going to predict the products. Double replacement just means that the potassium replaces the silver and the silver replaces the potassium. So it becomes silver chloride and potassium nitrate. Using the solubility rules, this guy is slightly soluble, so he is going to form a solid, a precipitate, and he is soluble. So this is my molecular equation for a precipitate reaction, because one of my products is a precipitate. So my molecular equation, now I'm going to balance it with coefficients. Silver, 1 silver, 1 silver, a nitrate, a potassium, a chloride, a chloride. It's balanced as written. I do not need to add any coefficients. They will not always be that simple. So make sure you balance it before you go on to the complete ionic equation. All right. The complete ionic equation is going to have all strong electrolytes separated into their ions. Right? Silver nitrate is a strong electrolyte. Why? Solubility rules tells me so. So I am going to write it as a strong electrolyte. Potassium chloride is a strong electrolyte based on solubility rules. Silver chloride is a solid. It is not a strong electrolyte, so it does not separate. Potassium nitrate are those spectator ions that are floating around in solution. This is my complete ionic equation. Now, what I'm going to do now is I am going to pick out my spectator ions and I am going to cross them out. Spectator ions are those ions that are not involved in the reaction. If you notice, I have a nitrate here and here. I have a potassium here and here. So I have crossed out my spectator ions. My net ionic equation, which I abbreviate NIE, will consist of the silver ion in its aqueous form and the chloride ion in its aqueous form, forming my solid, silver chloride. I do not separate it. It is not a strong electrolyte. And that is my net ionic equation for this metathesis reaction, which is a precipitate. All right, here's an example number 2. These examples, Here is example number 2. The rest of these examples are going to cover the gas producers. They are the hardest ones to recognize. There's some memorization you are going to have to do. Aqueous sodium sulfite, and if you recall from the previous video, I said that any sulfite salt with an acid will be a gas producer. So here are my reactants. This is going to be my molecular equation right here. I am going to do a double replacement reaction. I am going to get a salt, and I am going to get you have to recognize this in aqueous form. This is going to break apart. This is an interim substance. You have to recognize it. If you leave it written like this, you will be wrong. It will be marked wrong. You have to recognize the H2SO3. You're going to have to recognize that you have to erase it. Little voice inside your head said, nope, this is a gas producer. I am going to write out the proper gas. H2SO3 will form sulfur dioxide gas and water. And that's in its liquid form. You have to balance it, so I have to put a 2 here and a 2 here. My molecular equation is balanced. Now I'm going to write the complete ionic equation. The complete ionic equation separates the strong electrolytes. Sodium sulfite is a strong electrolyte based on solubility rules. The subscript pertains only to the sodium ion. Hydrochloric acid is a strong acid, therefore it is a strong electrolyte. It's got a coefficient. The coefficient is multiplied through the entire compound. Sodium chloride is a soluble salt based on solubility rules, and the coefficient multiplied through the entire compound. Sulfur dioxide gas is not a strong electrolyte, so do not separate it into its ions because it's not made of ions. And water is not a strong electrolyte, so do not separate it into its ions because it is not a strong electrolyte. You are only separating strong electrolytes, strong acids, strong bases, soluble salts. Do not separate weak acids, weak bases, water, solids, or gases. Now let's look for the spectator ions. You are looking for the exact same substance on the left of the arrow as on the right with the exact same coefficient. Notice sodium, chloride, and that's the only 2 spectator ions. Again, the story of 4 ions. 2 of them are brought out of the solution and 2 of them remain. The ones that remain in the solution are your spectator ions. My net ionic equation then is written as such, just like this. If you wish to rearrange the order of the reactants, that's fine. Example number 3. And again, this is a gas producer because these are the toughest to recognize. My molecular equation, potassium carbonate. Okay, so my voice inside my head says, remember that any carbonate plus an acid will be a gas producer. Well, this is a carbonate and an acid. So here are my reactants. It's a double replacement reaction, a metathesis. I switch the partners. I am going to get a soluble salt and carbonic acid, which I am going to recognize as a gas producer. I am not going to leave it like that because it's wrong. I am going to erase the carbonic acid and write down exactly what I remember: carbon dioxide gas and water. This is the molecular equation, and I need a 2 here and a 2 there in order to balance it. My complete ionic equation is going to separate the strong electrolytes. Potassium carbonate is a strong electrolyte based on solubility rules. The subscript only pertains to the potassium ion. You will notice that this partnership is also electrically balanced. Nitric acid is one of my strong acids, and it has a coefficient. Coefficients bleed through the entire compound, multiply through the entire compound. Potassium nitrate is a soluble salt, so it is a strong electrolyte. There is a coefficient, so the coefficient will apply to both the potassium and the nitrate. Now take a second and notice I have a 2 in front of this potassium on the right and a 2 on the left, a 2 in front of the nitrate, a 2 in front of the nitrate. So I know I'm doing this right. I'm checking my work as I go along. Carbon dioxide is a gas. It is not a strong electrolyte. Water is not a strong electrolyte. There's my complete ionic equation. I am going to cross out my spectator ions, which I can spot right away. They are identical and the exact same coefficient in front of, and they are floating around in solution. Those are the 2 ions that are basically doing nothing but floating. They are not involved in the reaction. My net ionic equation therefore becomes those ions involved in the reaction. And it's going to be a gas producer. And again, electrically and atomically balanced. Next example is the third gas producer. My molecular equation is going to be ammonium chloride, and these are all your ions that you are supposed to have memorized. Alright, there are my 2 reactants. It's a double replacement reaction. I have an ammonium salt and a strong base, so I am going to have a gas producer. I am going to get a salt, and I am going to get what I think is that, but a little bell goes off in my head and says this is a gas producer. This is an intermediate product, so I am going to erase that, because if I leave it like that I will get it wrong on the AP exam, and I am going to write the correct gas and water. And it's balanced, so my complete ionic equation are separating the strong electrolytes. Ammonium chloride is a soluble salt based on the solubility rules. Sodium hydroxide is a strong base, so it is a strong electrolyte. Sodium chloride is a soluble salt based on solubility rules. And ammonia gas is not. It is a gas, and liquid water is not. My complete ionic equation. Now I am going to cross out any spectator ions, and notice this guy and this guy. Now I'm going to write out my net ionic equation, and the net ionic equation are those ions responsible for the reaction. It is the equation that has no spectator ions in it. It is going to be balanced electrically and atomically. So look at it. 1 nitrogen on the left, 1 on the right, 4, 5 hydrogens on the left, 3, 4, 5 on the right, 1 oxygen, 1 oxygen, a 0 charge on the left, a 0 charge on the right, and it's done perfectly. Last example. This one's nice and simple. This is the 4th gas producer. I did not do a neutralization. Those are pretty simple. We can do one in class if you like, so make sure you ask. Iron 2 sulfide, that is a transition metal. That is iron with a 2+ charge, and sulfide is also a 2. So this is solid. So this doesn't start out as an aqueous solution, so it's a little different. Heated in hydrochloric acid, which is aqueous. Sometimes you might see that referring to heat. Double replacement reaction. I get iron 2 chloride, and it's a soluble because of the chloride based on solubility rules, and H2S gas. We got to balance it, so I'm going to put a coefficient of 2 here, and that's all I need for balancing. Now my complete ionic equation separating the strong electrolytes. This is not in solution, therefore it is not a strong electrolyte. It is a solid. Leave it alone. Hydrochloric acid is a strong acid. The coefficient multiplies through the entire compound. Iron chloride is a soluble salt based on the chloride, and it has a subscript for the chloride, so that only applies to the chloride. Beg your pardon. I'm starting to get a little tongue-tied here. And then you have, notice this is the last final gas producer. Notice you don't have to recognize anything when you do the double replacement reaction. It's a product right off the bat, so you don't have to recognize anything. I see only 1 spectator ion, which is fine. There might be no spectator ions. It really depends on what kind of reaction you're doing. So net ionic equation. I have my solid reactant, my hydrochloric acid, my aqueous solution. Can add that, doesn't matter. My aqueous ion here, and my gas. If I did this right, it will be balanced electrically and atomically.